Okay, section 8.2. One of the things we'll be talking about in this section has to do with the Cartesian coordinate plane. And the horizontal axis is called the x-axis. The vertical axis is called the y-axis. And all the equations that we'll be dealing with are linear equations. That means you can make a line out of them. So if we imagine a line, there's going to be 2 points on this that'll be of particular significance. The point where the line crosses the y-axis, right there, and the point where it crosses the x-axis, right there. This is called the y-intercept. And this is called the x-intercept. One thing about both of these, if we look at the y-intercept, we don't really know how far up it is. You know, depending on the scale, this could be 100 up. It could be 1 up. It could be 3 up. We don't know how far up it is. But as far as left to right goes, this point is 0 on the x-axis. It's not to the right at all. It's not to the left at all. It's just right at 0. So if we were coming up with an ordered pair for that, we don't know how far, like I said, we don't know how far up it is, but we do know the left-right movement is 0. So for the y-intercept, the x is 0. On the x-intercept, it's a similar idea. We don't know how far over we've gone, which is the x-coordinate. We don't know how far over we've gone, but as far as up or down, we know we've gone up 0, down 0. So our y-coordinate would be 0. We don't know what the x-coordinate is, like I said, because we don't know how far over we've come. But the x-intercept, the y is always 0. And for the y-intercept, the x is always 0. Okay, so a little bit of background. Not exactly what you'll be doing, but it's important to know. For the y-intercept, x is 0, and for the x-intercept, y is 0. So find the y-intercept and the x-intercept. So it's important to know that for the y-intercept, we can assume that x is 0. For the x-intercept, we can assume that y is 0. You're going to have to fill in these boxes. So if we start with the y-intercept, we're going to set x equal to 0. This is usually how I write it out. And then for the x-intercept, we're going to set y equal to 0. And we're given this equation up here to work with. So instead of, for the y-intercept, we're going to set x equal to 0. So 6 times 0 plus 4y, we don't know what y is yet, equals 15. For the x-intercept, this is on the other side of the line. We're going to set y equal to 0. So we've got 6. We don't know what x is, but we're going to set y equal to 0 for the x-intercept. So x is 0 and y is 0. So we'll work this out. 6 times 0 is just 0. So on the next line, we're just left with 4y equals 15. Divided by 4. And y equals 15 over 4. For the x-intercept, so we've got 15 over 4. So for the x-intercept, we've got 6x plus 4 times 0 equals 15. And 4 times 0 is just 0, so we're left with 6x equals 15. Divide by 6. And x equals 15 over 6, which we can reduce by 3. 15 divided by 3 is 5. 6 divided by 3 is 2. So when y is 0, x is 5 over 2. Find the y and x-intercept. So again, we've got the y-intercept where we've got two boxes next to it. The x-intercept where we've got two boxes next to it. And hopefully you'll remember that for the y-intercept, x is 0. And for the x-intercept, y is 0. Try to keep in mind that it's always x, y with these ordered pairs. So for the y-intercept, we're going to set x equal to 0. And for the x-intercept, set y equal to 0. So negative 5/4 times 0, x is 0, minus y equals negative 10. Nice thing about multiplying by 0 is that whole thing disappears. So negative 5/4 times 0 is just 0. So we've got negative y equals negative 10. And we don't want to know what negative y is. We want to know what positive y is. So one thing you can do is just change all the signs. If we want to change the sign of y, we just change all the signs. So y becomes positive. And if we change the sign of the negative 10, it becomes positive also. For the x-intercept, set y equal to 0. So we've got negative 5/4 x. And then this time y is 0. So over here, x was 0. Over here, y is 0. And again, this is the equation that we're using. So negative 5/4 x minus 0 is just negative 5/4 x. And from here, I would multiply 4. And we've done that in class. If you multiply 4, what happens is the divided by 4 and the multiplied by 4, those two cancel each other out. Make sure you do that on both sides, though. Multiply by 4 on the left, multiply by 4 on the right, and we end up with negative 5x equals negative 40. And then divided by negative 5. And we end up with x equals positive 8. Next, they'll give you some slightly different instructions. Use your knowledge of x and y intercepts to find the x and y intercept. So we're basically just doing the same thing, just a slightly different set of instructions, but you're just doing the same thing. They're not going to give us an x and y box or x and y intercept box, but doing the same thing. So we'll find the y-intercept first, setting x equal to 0, and then we'll find the x-intercept, setting y equal to 0. Okay, so on the left, I've set x equal to 0. So instead of 5 times x, we've got 5 times 0. On the right, I've set y equal to 0. So instead of 5x plus y, we've got 5x plus 0. And just going to work those out. 5 times 0 is just 0. So we just have y on the left equal to 5. So when x was 0, y is 5. And then continuing on with the second equation, 5x plus 0 equals 5. 5x plus 0 is just 5x. divided by 5. And 5 divided by 5 is just 1. Okay, graph the line by plotting any two ordered pairs. So slightly different instructions. And I'll say this, usually the easiest two ordered pairs to find are the x and y intercepts. These are the ones we've just done. They're not specifically saying those are the ones that we've got to find, but they're a good starting point. The only time that you'll need to do any different is, I'll do some examples here in a minute, but in some cases the x and y intercept are the exact same point, so we can't do it the normal way. But we'll go ahead and do that. On this one, we've got, we'll say two ordered pairs, and we'll let x be 0 on 1 and y be 0. So -4, and instead of x, we've got 0. And on the other one, we'll let y be 0. So again, x, -4 times 0, and then y, -2 times 0. -4 times 0 is 0, so we're left with the -2y equals -8. Divide -2. And then y equals negative divided by negative is positive. 8 divided by 2 is 4. Okay, moving on to the second group. -4x minus 2 times 0. 2 times 0 is just 0. So we're left with -4x equals -8. Divide -4. And x equals negative divided by negative is positive. 8 divided by 4 is 2. So we end up with 0, 4, and 2, 0. Okay, and these next few, the last ones in this section, these are all sort of shortcut ones. But you'll have to notice that x and y on the left equal to 0. X and y on the left, so we got 5x minus 9y on the left equal to 0. What this means is that one of the ordered pairs is going to be 0, 0. So you can just automatically enter that in. We're not going to do x and y intercepts on this one, but we will try so like I said, when you're in this situation, one of the ordered pairs that you can put in, and we do have to find two, one of the ordered pairs is going to be 0, 0 right off the bat. And then the other one, I would suggest entering in we're going to put 9 in for x. So for our second ordered pair, we're going to put in 9, and we'll see what we get for the output for y. And by the way, the reason I've chosen 9 is because we've got this 9 here. We could also put 5 in for y. which is the coefficient of x. So you're basically just swapping these. Instead of x, we're doing 9, or instead of y, we're doing 5. We're going to plug those in, or plug 1 in. And we've got 5 times 9 minus 9y equals 0. So 9 times 5 is 45, minus 9y equals 0. You're going to subtract 45. Got negative 9y equals negative 45. Divide negative 9. And y equals positive 5. And it will end up being the two coefficients, but the signs may not be the same. It might be 9 and negative 5, or it might be 5 and negative 9. So go through this process just to make sure you get your signs right. But these would be your two ordered pairs. And just to give you another example like that, if you've got, we'll say 3x minus 4y equals 0. Again, we've got x and y on the left equal to 0. When this happens, we know one of the ordered pairs is going to be 0, 0. We don't even have to plug anything in. And then for the second ordered pair, for x, we're going to plug in 4. And then you work that out and figure out what y is. It's going to be 3, maybe negative 3. Number 6, graph the line by plotting any two ordered pairs. So the last one was a bit of a shortcut because you've got x and y on the left equal to 0. A little bit different here. We've got y by itself equal to some fraction in front of x. So in this case, what I would recommend is use 0 for x, and we'll solve that. And the denominator, which in this case is 8 for x. And the reason these are good is because you might be able to do these in your head. If x is 0, so we're talking about now negative 1/8 times 0. Negative 1/8 times 0, this whole thing disappears. Negative 1/8 times 0 is just 0, so we're left with y equals, ignore this, 1. I'll go ahead and write that out, though. Y equals negative 1/8 times 0 plus 1. So that would be our first ordered pair. And then again, so we're using 0 to start with, because we got y by itself. And then we're going to do 8. And the reason we're doing 8 is because it's the denominator. If we had, just making this up, if we had y equals 1/3 x plus 4, in this case we would use 0. Hopefully you can do that pretty quick, because this whole term disappears if we use 0, and we're just left with 4. And then we would also use 3. So, and I'll show you why that's good to use. So if we use the denominator here, for x, anytime you're dividing by something and multiplying by something, here we're dividing by 8 and also multiplying by 8. Those two cancel each other out. And we're just left with the number on top, which is negative 1 plus 1. And y is equal to negative 1 plus 1 is just 0. So our second ordered pair, we went with 8, and then we ended up with y being 0 when we did that. Okay, hopefully you follow that one all right. This one here, like I said, we use 0, and then the whole fraction and x disappeared, and we're just left with the 4. If we do 3, though, if we make this 3, then those two cancel out, and we're just left with the 1 on top plus 4. So if you get the hang of this, it's pretty quick. You don't have to take too long to solve those ones where y is by itself. Okay, again, these are some shortcut ones. What I want you to notice on number 7, there's no x in the equation. So what that means, x doesn't matter. We can pick whatever x we want. We just have to have the right y. So solve for y. So in this case, getting y by itself is all we've got to be careful about. So I'm going to rewrite this. 3y equals 0. If we want to solve for y, we're going to divide by 3. And we get y equals 0 divided by anything is just 0. So we're looking for any two ordered pairs. So if y is equal to 0, since there's no x in the equation, x doesn't matter, but y must be 0. That's not always true if there's no x, but however you solve this, if y was 3, y must be 3. If there's no x, y has to be that. So anyways, on our ordered pairs that we're coming up with, our y, the second coordinate, in both of those has to be 0. And like I said, x doesn't matter. So you can just choose a random x. X does not matter. 5 and 4, 1 and 3, whatever you want to go with. Solve for y. Both of your y's have to be 0. But your x can be whatever. Okay, and the last one, similar to number 7, you want to notice there's no y in the equation. So same as when there was no x. Here, y doesn't matter. So when we finish this, we can throw in, we're looking for any two ordered pairs. So our y can be 7, it can be 3, it can be whatever, but we do need to solve for x. Y doesn't matter, solve for x. So on this one, we got negative 2x equals 6. If we want to get x by itself, we're going to divide by negative 2. And we end up with x equals negative 3. So in both of our ordered pairs, because we got to find two of them, x is going to have to be negative 3. But y does not matter. So 0, 1, whatever you want to do for y. Keep in mind it's x and then y all the time with ordered pairs. X and then y. So these would be our two ordered pairs. It doesn't necessarily have to be those two. It could be negative 3, 5. It could be negative 3, 7. As long as your x is negative 3, your y can be whatever. By the way, I don't know if anyone would do this, but you can't do negative 3, 0 and negative 3, 0 because those are the same point, and we've got to find 2 points, two ordered pairs.